Right. When you pump up oil, crude oil, you can't use it directly. You have to separate the crude oil into its components. And here's what you do: you take the crude oil and heat it in a furnace to about 400 degrees centigrade. And then you pass it through something called a fractioning column. In this fractioning column, different parts of the column are at different temperatures. So um, here's a chamber at 400 degrees Celsius. So here's what happens. Everything that has a boiling point over 400 less than 400 degrees Celsius is in gas form and is rising up. Anything that has a boiling point higher than 400 degrees Celsius, it's in liquid form and it falls through. And so lubricating oil, paraffin wax, and asphalt, their boiling point is above 400 degrees Celsius, so they fall in. So you've separated this stuff from the crude oil. Now let's get to this chamber. This chamber is at 370 degrees. Anything whose boiling point is below 370 degrees is in a gas form and it rises up. Anything that's whose boiling point is below 370 degrees condenses, and you get, and which one of those things is fuel oil, and you get oil out. So you see, from this, using this uh, fractioning column, you can separate crude oil into its various components. Okay, so diesel oil has a boiling temperature below 300 degrees Celsius, and uh, um, and it at 370 it was boiling and it was in gas form, and it came up and it's got a boiling temperature of below 300 degrees Celsius, and it condenses and comes out here. Kerosene has a boiling temperature below 200 degrees Celsius, and you get kerosene here, and you get gasoline at this thing, and this is natural gas. So using this fractioning column, which has chambers at different temperatures, what you've done is taken crude oil and separated it into its components. Now here's the rule of thumb: hydrocarbons with uh, more hydrocarbons are compounds that have hydrogen and carbon mostly in them, and the larger the number of carbon atoms, the higher the boiling point. So as you go higher and higher in the fractioning column, the lighter the hydrocarbon that you're getting. Okay. So here's how a fractioning column looks like. Again, this fractioning column is that thing right there. Okay. So so the refining process. So here are properties of typical hydrocarbons, and you see natural gas. This is the number of carbon atoms. Natural gas has methane has one carbon atom. So natural gas has many different compounds. So you see, as the number of carbon atoms increases, the boiling temperature increases. Okay, so kerosene has compounds that contain 12 to 16 carbon atoms, and the boiling temperature is between 175 to 275 degrees Celsius. Uh, let's look at a compound that has so paraff. Here's a lubricating oil is has more carbon atoms, and correspondingly its boiling point is higher. Okay. Alkanes are compounds that have only carbon and hydrogen. Okay. And these are compounds that have no double bonds, so all the carbon so there are no double bonds. So um, and so all the valence all the valence electrons of the carbon are satisfied. So um, here's methane, which is the main component of natural gas, and its molecular mass of that. And what this graph table also shows you is, so these are various hydrocarbons, alkanes with no double bonds, and this is the energy per joule. So million joules per kg energy million joules per kg of energy released when you burn these alkanes. This column shows you the energy in units called electron volts per molecule. Okay, and you can see that the greater the carbon number of carbon atoms, the greater the energy per molecule. But the greater the number of carbon atoms, the heavier the atom gets, and then the energy density decreases. But per molecule, you're getting more energy. So cracking is the process of breaking down larger hydrocarbon molecules into smaller hydrocarbon molecules. So to optimize the use of our petroleum resources, it's necessary to convert some of the less needed refinery products into more needed forms. Uh, so cracking mostly involves breaking down heavy hydrocarbons like tar and paraffin to make lighter hydrocarbons like octane, the main ingredient of gasoline. Okay, so yeah, by via cracking, you're breaking down less useful products into more useful products. And cracking just involves heating the hydrocarbon to high temperature to break down the chemical bonds. Yeah. So gasoline typically contains about 500 different hydrocarbons, 500 different kinds of compounds that have between 5 and 12 carbons. A substantial fraction of these hydrocarbon compounds of gasoline have a molecular mass similar to that of octane, an 8 carbon alkane. So this is octane. This is the octane molecule. And that's where the octane rating on your gasoline comes from. So natural gas, typically a mixture of 85% natural gas is typically 85% methane and 15% ethane. So here is methane, CH04. Let me show you ethane. This is ethane. C2H6 is ethane. Okay. So natural gas is 85% that and 15% that. Natural gas typically contains fewer impurities than heavier hydrocarbons and burns more efficiently. The smaller the hydrocarbon, the more complete burn you get. When you have a complete burn, all the carbon gets converted to carbon dioxide and all the hydrogen gets converted to water. So that's what a complete burn means. So smaller the molecule, the more complete burn you get, and the more energy you're releasing. Okay. All right, so here's where you will find natural gas. Will find natural gas in deposits of oil. So here's gas associated with oil deposits, or you can find natural gas by itself. And here's gas-rich shale rock, and also some coal beds and coal mines have methane in them. So those are the various locations where you find natural gas. Now, natural gas is a gas, and when it's in gas form, you can transport it via pipes over land. But if you want to bring it across the oceans, gas would take a large volume. So what you want to do is convert the gas to liquid, condense the gas to liquid. But this natural gas becomes liquid at minus 165 degrees Celsius. That's quite cold. So here are freezers containing liquid natural gas. All right, let's pause here.